Okay, we're on, we're ready. All right, now, what we're going to do is chapter 15. Now, chapter 15 is entitled what? Water and aqueous systems, something like that. What's it entitled?
Water and aqueous systems. Yeah.
Water and aqueous systems. Is that correct?
Mm-hmm.
What does the word aqueous mean? What's the word you think of when you think of aqueous? What is it? Water, yeah. Aqueous systems. Water and water systems, essentially, is what it says. Okay, and I have everything down. Today is what? Today's the 11th, is that correct? Day 5?
Yeah.
Okay, the test is going to be a week from Wednesday. Yeah, I feel the same way. Time's going really quickly. Daniel almost said a bad word. Almost. Okay, and then chapter 16 is going to be on the 28th, 1 week later. Now, there's a caveat there. It's probably going to be on that day. The night of the Ascension is currently scheduled for May 27th, correct? That's a Tuesday. Now that may be moved to Sunday. Either way, you're missing a day, right? So it's probably not going to be on Thursday, but it could be. Yes? Yes? So be flexible there. It's going to be approximately Wednesday the 28th, approximately. But because the night of the Ascension may be moved. Any word from my Muslim brethren here? Any word on the moving of the night of the Ascension? Could you do some research on that possibly? Anybody know what the story is? What is that?
You don't move the night of the Ascension.
Well, I heard that we might, yes, I'm aware of that. My apologies. I mean, no disrespect that you don't move the night of the Ascension. I understand that. But I thought there was talk about moving it to a Sunday or Thursday for the long weekend.
That's just a school.
Yes, I understand that, but that's what's affected. I know the night of the Ascension will be on the 27th. I have no problem with that. The celebration, however, is what's significant relative to whether or not it's attached to a weekend. Would you do some research on that, you two? See if you can find out. Because my students traditionally know, A, more than me, and 2, know it before me. So if you could do some research on that, I'll bet you're more correct than the administration. Okay, so what's the first thing we're going to study? Oh, and that's chapter 16, right? And then chapter 19, which is acid bases, we're skipping 17 and 18, and we're doing 19, is going to be on the 10th of June. You can write that down. June 10th. And that ends the year. And then either the 11th or the 12th will be the last day of instruction. Clear? And then you have exams. Yes?
Yeah, what about the final? Is it going to be another one?
It'll be all year.
All year?
It'll be all year. You have to. Chemistry has to be all year. Sorry, guys.
Wait, can you repeat that, sorry?
What is it?
Can you repeat that, please?
Chemistry exam will be from the beginning of the year. With the second half of the year stressed. But you can't do the second half of the year without the first half of the year. It is impossible. You can't do it. Clear? So as the year progressed, those units will become more important. Clear? Approximately. All right, so let's look at water and all its properties, okay? So the first thing we're going to look at is the molecule of water. What's the angle between the hydrogens? Anybody have that? The angle between the hydrogens. You want to look that up? What is the angle between the hydrogens in the molecule of water? Okay, water looks like this. Okay?
Isn't it 97 degrees, you told us?
I don't think I ever said it was 97 degrees. Yes?
Approximately 105.
Approximately 105. This angle here is approximately 105 degrees, give or take. Give or take. Yes? All right? Now, this is important. Remember we did electronegativity in chapter 5? So we're going back to chapter 5, and we're doing chapter 15. Remember, what is electronegativity? Does anybody remember what that is? Yes, Mustafa.
It's the likelihood of a atom taking electrons from another one.
Yes, that's pretty close. The likelihood of an atom taking electrons from another one. Okay. It's a tendency. Likelihood, I like that word, likelihood. It's a tendency for an atom to attract bonded electrons. Not non-bonded electrons, bonded electrons. A tendency for an atom in a molecule to attract bonded electrons. So what has a greater electronegativity? Can somebody look up the electronegativities in chapter 5? There's a chart of oxygen and hydrogen. Look up the electronegativities of hydrogen and oxygen. Now, so anyway, as some people are looking that up, oxygen has a greater electronegativity. So it gets an arrow with a tail on it. It's called a dipole moment. And that dipole moment is in the direction of the hydrogen. Now, let's take a blow up of that bond and see what it looks like. We're going to take a blow up of that bond and see what it looks like. It kind of looks like this. Okay? That's what the bond looks like. Here's hydrogen, here's oxygen.
37 tape.
And do we have
It's not on the tape.
it's not on the tape? What's not on the tape?
The
Yeah, I think it still may be. I have to let me broaden it here. Yeah, it's just there. It's pretty cool. Okay. All right. So, what was I saying? Yes. Does anybody have the electronegativity of oxygen and hydrogen, even if you have to look it up on the net? I know that you guys this is early in the morning. It's only 8:15 a.m. on a Sunday in the United Arab Emirates, but can you give me a look up on that? Okay. So, you'll see that most of the electricity is towards the hydrogen, is towards the oxygen. Most of the electrons are shifted towards the oxygen. So you're creating this asymmetrical, I like that word, asymmetrical distribution of the electrons. So you're creating this shift, this dipole. So what's going to happen is we use the letter lowercase delta to indicate the word partial. So you get this partial charge, this partial negative charge, because you have this shift of electrons. So it gains a little bit of a negative charge. As a result, what's going to happen to the hydrogen? What's going to happen to the hydrogen? That's going to do what? That's going to lose a little bit of a charge, and it's going to be a little positive. That'll be a little positive. So you get this dipole because you have this tendency to shift electrons, and that's going to be big. That's very, very big. So you have this dipole on each side of the bond, on each bond. Okay, because you have this greater electronegativity. Now you guys are looking that up. You guys look completely stunned. Go back, right there's a book. Go to the index. Go to the index.
I got it online.
She's got it online. Excellent. Abby, you are a wonderful person. Extra credit reminded me. I like that.
On the Pauling scale?
Whatever. That's fine.
3.44 for oxygen.
All right, so that's 3 electronegativity.
And 2.20.
Electronegativity is 3.44 for oxygen and 2.20?
2.20, yeah.
2.20 for hydrogen. So you can see that the difference in electronegativity between hydrogen and oxygen is significant, isn't it? It's significant. Now, as a result, let's say I'm flying in an airplane, a jet. Okay? I'm going to, I don't know, France, okay? And I'm flying in a jet. I'm flying that way. Actually, no. let's say we're not flying that way. Let's say we're flying straight up and down. Okay? Let's say we're flying to France. Okay? Now, I have this giant wind, not as fast as the plane is going, but significant, going like this. Okay? What's going to happen to the vector? What's going to happen to the flight path of the jet? It's going to shift, isn't it? It's going to kind of go like this, isn't it? Yes? Yes? It's going to shift. So there are forces that are pushing that airplane or shifting it, aren't they? Yes? Okay, so the same thing is true with this. If I have a vector pushing this way, and I have another vector pushing that way, both are equal, where do you think, if those things were actual forces, where do you think, what would be the direction, Enzo? It would be straight up. So as a result, we get this net dipole. This net dipole. Okay, are you ready for this definition? This is something that should be familiar to you. When a molecule, such as water, has a net dipole, we say that the molecule is polar. That's what you're going to say, right, Mustafa? Excellent. I understand. Absolutely. So when a molecule has a net dipole, it's polar. Now, let's look back and see where did this start with? What was actually polar in order for the molecule to be polar? Correct. The bonds had to be polar. If you don't have polar bonds, you're not going to have a polar molecule, are you? Okay? So the bonds have to be polar. Let me ask you a question. Because we live in a relative world. Give me an example of a molecule that has polar bonds but is not polar. Anybody do that quickly?
Carbon.
Carbon and what?
And carbon. More carbon.
Carbon and more carbon and more carbon and carbon. You cook with it.
Butane.
What is it?
Butane.
Yeah, some of you cook with butane, I suppose. LPG, liquid petroleum gas, kind of dangerous. But what else do you cook with? What's another kind of gas that's popular? Safer. Anybody starts with an M?
Methane.
Methane, yeah. Methane looks like this. Now, Abby, what are the electronegativities of carbon and hydrogen? We know carbon is 2.2. Carbon is 2.2. I'm sorry, hydrogen is 2.2. Thank you, Pranita. Hydrogen is 2.2. Anybody know what carbon is? Yes.
No, it's just carbon.
Carbon. The electronegativity of carbon.
I'm just saying it's
Higher than
2.1.
2.2.
It's just
Yeah, we're saying it's 2.2. That's what Abby gave us. 2.1, 2.2, close enough. What's carbon, though?
According to the website.
Pons? Is that what? Pons? Is that what it is?
It's
it's
Pauling.
2.5.
What is it?
By Pauling's electronegativity.
Pauling.
Uh-huh.
Who's Pauling?
Well, the guy from the Pauli exclusion principle.
Yeah.
Okay.
2.5.
The guy from the Pauli exclusion principle. So it's the Pauli table
Yeah.
or Pauling?
So 2.5.
Is it Pauling or Pauli?
Pauling.
Pauling, L-I-N-G, right?
It's not Pauli.
So where's Pauling come from? Who's Pauling? What's his first name?
Paul.
Pauling's first name is Paul.
Actually,
That's a really bad guess, but I understand that it was for a punchline. I understand that, but what's Pauling's first name? Anybody know? Want to look that up? So what was it? What was carbon's electronegativity?
2.5.
2.5. So we have the dipoles going towards hydrogen, right? I'm sorry, going towards carbon.
Yeah.
One sir.
Yes.
Calling first name Linus.
What is it? Linus. Well, Linus, depends where you come from. You're probably pronouncing it correct because of your European roots. Yes. You ever see Peanuts, the Peanuts cartoon? You ever see Peanuts? What's one of the characters in Peanuts?
Linus.
Linus, yeah. Linus Pauling. Look at vitamin C. Why do we take large quantities of vitamin C? Believe it or not, because of Linus Pauling, same guy. Okay, so, but are all of these bonds, are they equally distributed around the carbon? Yeah, there's no net dipole. No net dipole. So therefore the molecule is nonpolar. So this is nonpolar. Okay, you get it? So yeah, water is polar, and what does it mean when something's nonpolar? It simply means that its polar bonds are evenly distributed, and the dipoles cancel, and there's no net dipole. Are things making a little bit more sense to you? I'm getting that impression. And so you don't seem to be as crazy. You don't seem to be as on edge during class. I know you don't get crazy, but my interpretation is you seem to be more comfortable with the material. Things are starting to make a little sense. I get that impression. Okay. All right, good. So what we're going to do is we're going to write water like this. From now on, I'm just simply going to say that water is like this. That's water. And we know that you have a partial positive and a partial negative. We know that. Okay? Well, we're just going to write water as this angular or bent molecule. Clear? Okay? So we're going to stop right there. We're going to call, what shall we call this? We'll call this the polarity of water. Or what are we going to call this? Electronegativity part 1 now, because the focus was not necessarily on electronegativity. We're going to call the polarity of water. We're off. I don't want to make them too long.